Okay, in this video, we're going to get more advanced with our zones. So at this point, what we're looking at here are three zones created through the standard zone method. So we took the composite of multiple years and we've zoned it into three zones: low, medium, high productivity, based on that composite layer. So we need to make sure that we have the zones set up here how we like them, how we want them. So if you're happy with the three zone, the next thing we're going to do is we're going to break down zone one and use topography to actually tell us whether potentially it's low producing because it's a hilltop, or maybe a low-lying wet area, or maybe another reason that topography doesn't account for. So you need to create your zones in the zone tab and be looking at them like that, and then you can move over to the topo tab. Now, depending on where you are, you have the ability to automatically fetch LiDAR if you're in an area that currently has public LiDAR. If you don't have LiDAR available, then you also have the option to upload elevation points. And if you are in that situation, there's detailed information in the user manual of exactly what we need for that. But as a general overview, it has to be a point shape file. It needs to be RTK quality elevation. It needs to be in the same WGS84 lat long coordinate system. And you need to zip it all into a shape file, into a zip file, and upload it here, and then specify the column that contains the elevation values and the units, and then we'll take it and do the rest. So ideally, if you're in LiDAR coverage, you're going to use LiDAR. But again, if you or your clients have RTK elevation, maybe from the combine or from a seeder or something, then you can use that as well. It'll just take a little bit more work to get it prepared so that you can use it in here. So this field luckily is in an area where we have LiDAR. So all I need to do is just make sure I've selected the correct region. So you need to select either the US or Canada. In this case, we're in Canada. So we're going to now fetch and process the LiDAR. So it takes a few seconds just to fetch and download LiDAR for the field. And then we're actually now uploading it to our cloud server, where it's getting analyzed and processed and doing things that we can't do just in your web browser. So you do need to be online with a reasonably good internet connection to do this, because it is sending the data to the cloud. And it'll take usually about 30 seconds. And you'll see this spinner. Once it's completed, the spinner will disappear. And what you'll see initially is you'll still see your original zones, but now they'll be laid on top of a kind of a bit of a 3D textured background. And the other thing that'll become available now is the 3D viewer. So you can click on that, it'll open a new little window, and now we can actually get the 3D view of the field. And if you're on a computer with a keyboard, if you hold down Control and your left mouse button, you can rotate. If you just hold down the left mouse button, you can pan around, and you can use the right mouse button to zoom in and out. Just right mouse button and then just move the mouse back and forwards to zoom in and out. So what we're looking for here are some of our zone ones. Are they potentially, as a result, maybe here, of being on the top of a hill? Could that be why they're low producing? Whereas maybe some of these zone ones down here look like they're quite low. They could be zone one low producing for a very different reason. And that's kind of the goal of this advanced topo. We call it refined zones. So a little bit to understand here. Once you've created the elevation, once we've got that loaded in, and we've got this wetness layer loaded in as well, you need to decide what you want to do here. So we've got a threshold for dry and a threshold for wet, and you need to adjust these sliders, or maybe you can just run it the first time and just leave it as is, and I'll just do that and then I'll explain what it did. So what we did here is we have this wetness index, and usually the values are between 0 and 100. So where 0 is very, very dry, like a top of a hill, and a value of 100 would be the wettest area in the field. So by default, we're saying that anywhere where we found a zone 1 that was below 40, we're now going to classify it as a dry limited area. And anywhere that we found that was above 60, we're going to classify that as a wet limited area. And then anything that doesn't fit in between those at all, we're actually going to create another zone called, this will be our other limited zone. So in this case, we took the initial zone 1 and we've turned it into 3 zones. We've got zone 1, which is now dry limited, zone 2 is wet limited, zone 3 is other limited. So they were all originally in zone 1. That's the important thing to remember here. Okay, so because we had a split, we took everything under 40 and over 60, we ended up creating 3 zones out of that one zone. If you don't want to do that, you could set them both, say, at 50-50, and then run it again. And what it'll do this time is it'll just create a zone 1, so it'll say anything that was below 50, we're now saying it's dry limited, and anything that was above, we're saying is wet limited. But you could also do it something like that. So you could set them both at say 60. So that would now mean that anything below 60 is going to be classified as dry, anything above 60 is going to be classified as wet. And again, you can run the analysis now. So it'll take a little bit of learning, playing around what works for you, and maybe different for different fields. But in general, I'm going to assume, especially on smaller fields, that you're probably going to want to split zone 1 just into 2. But maybe on larger fields, you may not. So again, let's assume that we just go back to the default values, and I'll show you what it's telling us now. So what we have now are these brown zones. So that used to be zone 1, it used to be our red zone when we only had 3 zones. And now this is saying that this most likely correlates with topography, and it's probably a dry zone. We could see in the 3D map, and if we look at the 3D map now, we can see, for example, that that's a ridge or a hill, and it has very low wetness potential. So potentially, if it is not performing well, not yielding well, it's probably a moisture issue in that area. Likewise, some of these low areas now have been picked out as related to maybe excess wetness, and that may be the limiting factor. And again, the 3D map will show you what it's done. And it's also, in this case, found that some of these areas are not necessarily within that threshold. So we have got some yellow areas here. Again, being a small field like this, I would probably just set these to be 50-50 so that we don't end up with just some small other zones. And now we've turned our original 3 zone into 4 zones because we've split the low productivity into the 2 different topography classifications. So again, you can play around in here and make some adjustments, and you've got also the minimum zone size that we can enforce in here as well. And what we can also do here is, because we now have the productivity from the NDVI composite, and we have the wetness information, if you click on that one, it'll actually show us a plot, and it shows you what happens through the field as these values change. So this one's quite interesting, actually, because what we're seeing here is that where we have lower wetness, we tend to have a curve with lower productivity as well, lower CPI or NDVI averages. And then that peaks right around the 60-65 sort of wetness, and then as the field starts to get a little bit wetter, you can see the curve comes down. But the trend actually in this case looks like the The drier zone 1 areas maybe are slightly less productive, and we see slightly higher productivity in the wet areas. So again, this is just a tool. It's not 100% guaranteed that it's going to tell you all of the answers, but it's something that you can look at just to see, and you'll see on some fields that it'll be a straight line, and in some cases the wetter areas seem to produce better, and you'll see different shapes of curves on different landscapes, different fields, different soils. Once you've created these as well, there is also the transparency slider, and because we now have the LiDAR, you can kind of see that against the wetness LiDAR layer in the background, and that helps you visualize, you know, what's been assigned what. And in general, on this field, it does seem to make sense. So again, if you're happy with what you've got, whatever you're viewing becomes the exportable layer. Okay, so if we now go to export and we exported a shapefile, this shapefile will represent these zones. If I went back to the zones tab, it'll recompute the standard zones. And now if I were to make an export, it would be based on these zones again. So then if I wanted to go back to the topo zones, I would have to come back, create them again. But if you did want to maybe make a change, like maybe you had 5 zones and you wanted to actually change to 3 zones, then you could come back to the zone tab, make your changes here. Maybe let's go to 4 zones. And then we'll come back to the topo tab and we'll create the refined zones now based on those new zones. So now we would actually have a total of 5 zones because we took our initial 4, we split zone 1, and now we have a 5 zone map. So again, you can manipulate this however you like. Just remember that whatever you're looking at on the map, if you then go to export, that's what's going to be exported. Likewise, if you're using any of the soil sampling or the prescription tool and you're loading in the current zone map, that's going to take the currently displayed zone layer as well. So again, have a play with it, and if you are using the shapefile points, make sure you read the manual, make sure you understand what you need to do for that, and see how you make out.